All right, so this little video is talking about your project. You have come up with a topic and a question. You've gathered some data. Now your job is to analyze the data. So many of you have started on this. I just want to go over some key points. If you can analyze your data with these key mathematical measures, you will have a better understanding of how that data works, and your mark will be better on the project. I'll just be honest with you. So what you want to do is you want to use as many analyzing tools, mathematical analyzing tools as possible. And as we've already talked about, the mean, the median, and the mode are three measures of central tendency. The mean is the average, the median would be the middle number when they're arranged from smallest to greatest, and the mode is the one that appears most often. Each of them have a significance in analyzing your data. Okay? Obviously the average is one that's most commonly used. We also talk about outliers. Outliers would be those data points, maybe 1, maybe 2, maybe 3 out of 50, that would be vastly different than the rest of them. Okay? And so those ones often can be legitimately discounted because they would affect the group's measurement unfairly. So you can look for outliers. And technically, outliers are data points that are, I think, beyond 1.5 standard deviations from the mean, which you don't know much about that yet, but we'll get into that. Outliers. Okay, so here we go. Measure of dispersion. We talked a little bit about this, about the standard deviation. If a group of data is really closely grouped, it has a small deviation. So they don't deviate from each other much. If the data in the group has a large dispersion, that's a standard deviation would be larger. So how do you find standard deviation? Okay, let's just take a look at this. On a graphing calculator, we have some in the class here. Let's just take, for example, in my calculator, list 2. Okay, so you can see I have a bunch of data points in list 2. And this is very important, so you all should be watching this here. If you want to find the standard deviations, really, really easy. You go to Stats and over to Calculate. And then number 1, and this is the screen we've been to for the regression models, right? But look at number 1 var stats. If you do that, you hit that, the calculator, and I've already done this before, the calculator will give you the stats from whatever list you choose. So I'm going to choose list 2, and I'm going to hit enter. And the calculator automatically gives you some important features. So X bar, that's how you say this, that's the mean. Okay? So the average of those data points that I put in is 25.88 repeating. All right, this is the sum of all of them. This is the sum of the squares of all of them. These aren't really important. This is the standard deviation for the sample size itself. This sigma x, this is a Greek letter, sigma. It's a lowercase sigma. This is the standard deviation right here, sigma x. And so 20 doesn't really mean much, I guess, for you right now. But if you had a couple, sets of data, the lower the number, the better. Okay. And anyway, so we won't get too far into it. But this is the standard deviation, and for now, you can simply state the standard deviation, and when you do your analysis. The other things that this calculates for you is the number of items was 9. The minimum, the smallest one, is 2. These are quartiles. You don't need to worry too much about those. Median is 23. That's the middle number, and the maximum is 64. So this is an important set of data, stats, that you can include with your data. Okay? Do you have to know exactly what 20 as a standard deviation actually means right now? No, but if you have a number of sets of data, and you do these stats on a number of sets of data, you can compare standard deviations and know which ones maybe are a little bit more reliable or a little bit more consistent, right? It's a measure of consistency. So that's standard deviation. The normal distribution z-scores. Okay, so z-scores, this is a formula for z-scores. You would take one data point, subtract the mean, and divide it by the standard deviation. And what this does is it sort of tells you where in the group that data point lies. So is it near the bottom? Is it near the top? Is it right in the middle? It kind of gives you a number score, and it literally tells you, how many data points or what percentage of the data is less than that, or what percentage would be greater than that. And so z-scores are something that, did we cover this in this class at all, z-scores with this class? I don't think so. I think that was in another class. So anyways, so I'll talk a little bit more about z-scores later, but if we read here, when working with several sets of data that approximate normal distributions, so that's like a little bit on the low end, a little bit on the top end, and the bulk in the middle, kind of that Gaussian sort of bell curve, you can use z-scores to compare the data values. A z-score table enables you to find the area under a normal distribution curve with a mean of 0 and a standard deviation of 1. To determine the z-score for any data value in a set, you use this formula. And so if we're working with percentiles, right, like if you had, let's say your test score. If you had your test score, you knew the mean and the standard deviation, you could tell what percentile your test score lands in. If it was in the 85th percentile, that means that roughly 85% of all the other marks were lower than yours, and only 15 was greater than yours. So z-scores can compare one data value with the rest of the set. Okay, real quickly, just one more thing to mention. If you are analyzing polls or surveys, often these surveys come with two things: margin of error and confidence level. So let me just pick it up here. A survey may have a margin of error of plus or minus 3%. All right, so that basically means that, hey, here's what I found, but it could be 3% higher or 3% lower. That's what it means. Because when you survey something, you never get the exact, 100% confident value. You get your best approximation based on the survey. Now this one, the 95% confidence level, is something that's a little bit more enigmatic, but it means that, basically it means that this data value, the actual one, will be plus or minus 3% from the value that you've stated 95 times out of 100. So it's like I am confident that the actual value is within this margin of error 95 times out of 100. So again, it's just another sort of indicator of how reliable the data is. All right? So obviously, if you have fewer data points and you're doing all this data on, that's not going to be very reliable, right? If you have 9 data points like I did, it's not going to be very reliable. You're not going to be able to say, this is representation of the entire world, right? 9. If you have 9,000 and you do this data on it, then you would have a higher confidence that this is representing maybe closer to the entire world or the population of the province or whatever, right? Okay, so larger sample sizes are best. All right, so I'll let you read through this example on your own. Okay, I want you to read the project example here, and it talks about Walter here and his decisions on what sort of data analysis, what sort of mathematical tools he's going to use to analyze his data. And again, I want you to use as many as possible to analyze your data, and then I want you to take a look at those and tell me what those tell you about your data and about answering your question. So you can go ahead and read this, and yeah, there's some questions for you to reflect upon. Okay, take a moment to do that. So I'll let you see this here again on screen.